Okay, so this is going to be a quick summary of the main ideas for this week. And so the idea, the main points that we want to get through this week is the main quantities that we're going to use to describe systems, right? So we have pressure, we have volume, then we have temperature, we have density, and we have number density. Along with that, we have the idea of mole, and then we have the idea of atomic mass or molecular mass, and then we have the idea of molar mass. So these are the quantities that we want to write equations with and that we want to study and see how they behave. With pressure, we looked at in the previous class. Pressure is just if you have an area and then you apply a force on that area, then you take the force, you divide the force by the area, and you get the pressure. And the units of pressure are, well, the units of force, which are Newton, divided by the units of area, which are meters squared. And we have a name for this. This is called a Pascal. And a Pascal is just a tiny unit. So in some cases we need bigger units, so we define the ATM. And 1 ATM is roughly 100,000 Pascal. The exact number is in your book, so you can look it up if you want. So that's the pressure. Pressure is due to the collisions of the many particles with the walls of the container. So it's basically a force due to these many collisions with the particles. So if you have a gas in a box, and then you have particles, these particles are going to travel and collide. And every time there's a collision, there is a force. And if you add all those collisions, then you get a pressure. So let me show you a quick simulation of an ideal gas. So to have a better idea of the pressure. So here we have an ideal gas, and the main point here is that the particles don't interact with each other except for rare collisions. And then you get these collisions with the walls, and those collisions with the walls are what causes the pressure. So that's one of the main concepts that we want to study, pressure. Along with that, we want to look at volume, right? So volume, well, we know what that is. So what are the units of volumes? Typically, you get meter cube, you get centimeter cube, and then you get liters and milliliters, right? So 1 meter cube is roughly 10 to the 6 centimeter cube, and 1 liter is 1000 milliliters, which is 1000 centimeter cubes. Those are units that is nice to have an idea about and to remember, but at least you should have an intuition. So we have pressure, volume, so we have the systems that we're going to study. So we have the systems, and they come in 3 flavors that we are going to look at. They come in gases, they come as gases, solids, or liquids. And so in most cases for this class we're going to study gases. So we're just going to look a little bit at solid and liquids. Gases are just particles that are kind of far apart. They don't interact with each other. And so the main properties of gases is that they flow, they exert pressure on the container, right? And they are compressible. That means you can change the volume. If you squeeze a balloon with a gas, you can change the volume. Then there is liquids. They have a free surface, typically, only if they are filling the container. And they flow. And also they exert pressure, but not in all walls because there is a free surface. Right? So they exert pressure and they are incompressible. In general, they are not really incompressible, but it's really hard to change the volume. So for all practical purposes, we're going to consider that liquids are incompressible. And then finally, we have solids. And then solids are particles that are tightly bound, right? They are bound and the shape doesn't change. So one main difference between liquid, gases, and solids is that you can shear, right? So you can deform liquids and gases very easily, but solids, if you deform them, they come back to the original, in most cases, they come back to the original shape. Okay, so we have those ideas, so we can also define, along with that, we can define the idea of density. And density is just the mass that we have divided by the volume. So mass we measure in kilograms. From your physics one, you remember that. Volume we measure in meter cubes. So now we have mass divided by volume. So this is the units of density. We also have the number density. And the number density is just the number of particles divided by the volume, and the units are 1 over meter cube or 1 over the volume. Alright, so with that in mind, then we can move ahead and look at a little bit some of the properties of liquid, solid, and gases. So you have, let's say you have a solid, right, like ice, and then you add heat. You start heating it up, right? So you put some flame here, right? Some flame, and then this is heat going into the ice, and then you know what happens. This is going to melt, and it's going to become a liquid, right? And then you have a container here, right, that holds the ice. And then if you keep heating up, if you keep adding heat, then eventually this is going to become a gas, right? And then it's going to become vapor, right? So then we have these properties that liquid solids they melt, and then liquids basically they become gas, and then they boil, right? And you can go the other way around. You can condense and then you can solidify. So you can do that by changing the temperature. So in most cases, for this class, we're going to study gases, and we're going to study the pressure, volume, temperature, and number of particles for the gas. So that's what most of this class is going to concentrate on. Look at this one system. and it's called the ideal gas. So, and we'll explain later why the word ideal and what all that means, but that's basically what we are going to be doing for most of the time. Let me give you some values for density so we have an idea. For the two most important values for density, air is 1.28 kilograms per meter cube. Imagine a box that is 1 meter per 1 meter, 1 meter, and 1 meter, right? A box that big. So then that box has 1 kilogram. So if you put the air on that box on a scale, what you're going to measure is 1.28 kilograms. If you do the same for water, right, so this becomes 1,000. So as you can see, water is much heavier, it's 1,000 times heavier than air per unit of volume. Okay, so now let's look at another important concept here, which is moles and the idea of atomic mass. So we're going to start with atomic mass, right? And the atomic mass is what it says, is the mass of one atom. The mass of one atom, right? And so, and there is a unit for atomic mass, which is the mass of one hydrogen atom. And this is 1.66 times 10 to the minus 27 kilograms. That is the mass of one hydrogen atom. And then the idea of mole, right? Mole is just a name for a big number. 1 mole is 6.022 times 10 to the 23, and it doesn't have units because it's a mole, right? This is also called the Avogadro's number, and sometimes it's written as Na. And then we have what is called the molar mass. So if you take 1 mole of carbon, right, for 1 mole of carbon, right? So, well, there are 6 times 10 to the 23, okay, atoms in that mole, right? And if you multiply that number by the mass of one carbon atom, you get the molar mass. So that's an important quantity. So if you take the number of particles, if you take the total mass and you divide by the molar mass, what you get is the number of moles, right? So so the molar mass is an important quantity that we are going to study. And then if you take, and typically the number of moles is denoted with a little n, sorry about that. If you take the mass of one atom, if you take the mass, the total mass, and divide that by the mass of one atom, you get the total number of particles. This is number of moles. And this one here is number